All right, so we're going to start with number 17 here, where we have the three-way incandescent light bulb. All right? And really what they're setting up here is a circuit with two resistors in series. So, and using the idea of power. So I included the diagram in my Y, because that would be a good thing to have. But I would definitely start off with what power is. You know, power is the rate energy is used by bulb. And then it is controlled by the amount of energy delivered and the rate it is delivered. All right? So that's probably what I would have for my Y. I might even go into making sure I showed I understood what current and resistance and voltage were, but maybe not. And then over here, I might as well put all of, I know it's either, I'm either going to use IB or V squared over R for my equations. Just the only reason I suspect that is because they tell me that the constant here is that there's 120 volts across the bulb. So that I'm thinking that I'm going to need my power equations that involve voltage to make my life easier. So when A and B are connected, it uses 85 watts. So let's see, power AB equals 85 watts. AC 45 watts. Power AC right? And that's all they tell me, right? And then they want to know what resistance 1 is and resistance 2 is. And what else? Any other interesting things? And how much power does bulb use when it's connected to BC? All right. So let's take that AB first, because that only involves resistor 1. So this part A, I guess. So power AB equals V squared over R1. And then just substitute in, right? 85 watts equals 120 volts squared over R1. Solve for R1. And that would be end up in ohms because it's watts and volts. Well, the V is the units, so you would have to square those also. Yes. Yeah. Everything in the parentheses. And then for part B, power of AC equals V squared over. Now, between A and C, we have the two resistors, And I know they're in series, so they combine R1 plus R2. And then I can just do my substitution again, right? Because I know that that's 45 watts. And again, my voltage hasn't changed. That's my consistent. I'll know R1 because I will have done the first part, and then I can just solve for R2. Right. And then the last part, part C, they want to know what's the power when it's connected between BC. And again, I'm going to use V squared over R, and this time it would just be R2. And I'm sure that you can, after practicing the first two parts, you can use those skills to get the third part. Right? Let me know if there's any questions. All right, so number 6, we're given some resistances, and we're asked to find the equivalent resistance, right? So for this one, if you have this type of problem, I think your Y only needs to really be the diagrams that you would use. So I'm going to cheat and start off with their diagram. So number 6, and let me just get my values. R1 is 29 ohms. R2 is 51 ohms. R3 is 82 ohms. And now, one of the things to remember is I can only combine resistors that are either strictly in parallel or strictly in series. And so let's throw those equations up here. So that I get credit for correct physics equations. So right now, the only resistors that are in any relation to each other are R1 and R2. Because they're in series to each other, but they're not in any relationship to R3 yet. So my first step in my first redrawing, excuse how messy this is on the board, but is going to be to combine those two. So this is still R3. We'll call this R12, just to give it a name.
Oh, you're combining them.
Yes.
Yes.
And now those are in, though now resistor 1, 2 and resistor 3 are in parallel to each other, so I can combine those into a single resistor. We'll just call it R123. And that's what they're asking for. What is the value of R123? So to go this first step, call that step A. I need to combine those two, so I'm going to use that they're in series. So resistor 1, 2 equals 29 ohms plus 51 ohms. So for me, it's 80 ohms. And then to do the next step, which I'll call B, I need to do 1 over R123 equals 1 over 80 ohms plus 1 over 82 ohms. Oh darn, I just missed being able to do it in my head. Probably the most common mistake will be to forget to take the reciprocal of your final answer. So 80, reciprocal of 80 plus reciprocal of 82, take the reciprocal of that, and I've got 40.5. I use what's known as the reciprocal key, which has the symbol x to the minus 1. All right, so we're going to do number 15. Basically, they give us this battery, and then they ask us all about the currents. So, we know how to do this, right? Because we've done lots of circuits. Let's see. I'm going to draw my battery. We'll come up to our resistors, which are horribly drawn. Actually, I'm going to redraw that slightly. I like how it was attaching. That stupid parasol. You're excused. All right, so there's my circuit. Easy peasy, right? 88, 130, 270. 88, 270, 130. Volts. Right? And then, of course, I would just do my currents. Out of the positive, I'm going to call that I1. We'll call this I2, I3, I4. And I don't even think I need to plot it, so I'm going to kind of skip that part of the Y. But we'll just generate our equations. I think I'll use this empty space. And there's one junction, right? I1 equals I2 plus I3 plus I4. That single junction. And there are a total of, let's see, 3, 4, 5, 6 loops. So I would start off 12 minus 88 I2 equals 0. 12 minus 130 I3 equals 0. 12 minus 270 I4 equals 0. I don't even think I need to use the linear solver to be done, because I can solve algebraic equations that have one unknown. And once I solve the 3 loops, I have 3 out of the 4 unknowns in the junction, and I'm done.